Approximately 7% of the world's oil is used in polymer production. About 94% of these polymers eventually end up in landfills, where they sit for eternity. Polyflow Corporation has developed a revolutionary process to convert polymer waste from an environmental burden to an alternative to crude oil. A unique and key feature of this process is the ability to consume mixed polymer waste. This means no sorting and a tolerance for contaminants such as paper labels and cap liners, metal fasteners and hinges in e-waste, and wire and tires, glass, adhesives, dirt in used carpet, paint, ink, oils, etc. However, only the polymeric materials are converted. To demonstrate the chemistry of the patent-pending process, we are currently operating a batch unit to explore the effect of process and feed variables on the end products. The process is very robust and has yielded results showing the consistent production of valuable aromatic chemicals, completely validating the chemistry and its potential value. The process does not require the addition of catalysts or other materials to enable the conversion. The process uses less than 10% of the fuel value of the polymer feedstock to complete the conversion, and convert 70% of the feedstock to product. Here we see examples of shredded rubber tires, carpeting, off-spec material from injection molding compound, end-of-life blow-molded toys, contaminated construction buckets, packaging films, pop bottles, and milk jugs. These are representative of the world of polymer waste arriving daily at your local landfill. After the Polyflow batch processor is loaded, the hatch cover is bolted in place. The unit is purged to reduce the oxygen inside the unit. Heat is then applied to the processor. A production unit, which is the next step in our technology commercialization, will operate continuously, eliminating the need for heat up and cool down between batches, as well as the manual loading steps shown previously. In addition to the liquid product, a light gas is produced, which we currently burn. In a full production facility, this gas will provide energy to run the process. Many of the previous attempts at polymer pyrolysis have produced heavy fuel oil liquids whose only value is the heat they can produce when burned. This results in the equivalent of a delayed burning of the plastics to create energy. In contrast, the Polyflow process yields a low viscosity liquid rich in aromatic chemicals. These aromatics are high-value materials used in the manufacture of virgin polymers and as building blocks to produce industrial and commercial chemicals and products like synthetic rubber, plastic molding compounds, paints, adhesives, etc. In addition, Polyflow's production of the liquid product will generate 70% less carbon dioxide than the outdated fuel oil processes or burning plastic in waste-to-energy plants. Many polymer products contain fillers and reinforcing materials. For example, scrap tires contain carbon black and steel, which account for about 50% of their weight. These fillers and other inert materials will be recovered from the process and separated to recover metals, glass, and a char which may be burned as fuel. Here we see that the char is easily crushed and the steel wire from the tires can be removed by magnetic separation. We anticipate the production plant will obtain 90% of its energy requirements from burning the char and off gases of the process. With a virtually endless supply of raw material and a robust process, Polyflow Corporation will provide the solution to the end-of-life issues surrounding polymers and create an alternative to crude oil for the world's polymer needs.